So for this next presentation, to wind this one up, what I'd like to say is, again, the themes that we want to push here are new technology, detection, and really forward-looking, like what are we going to do as a blue team to make sure we stay ahead of attackers and aren't just responding to them. And this is another presentation that perfectly nails that. It takes a lot of the concepts that it takes for blue teams to win involving sharing and standardization with MITRE ATT&CK and DeTT&CT, as we'll talk about here, and some of the new technology that this is going to be applied to. So Kubernetes, containers, cloud infrastructure, and detection of when things go wrong with them. So again, overlapping all over on the Venn diagram of good things we want to know about here. We have Magna Logan here to speak on detecting Kubernetes attacks with audit logs. So I will pass it over to you.
Thank you, John. Yeah, can everyone see me and hear me well? Just double checking here.
All yep, good? That's good.
Okay, thank you. Let's see. Can I put the slides? Okay, got it. Yeah, so the topic for this presentation is detecting Kubernetes attacks with audit logs, right? So there is a play of the words there. We're gonna talk a little bit about the tech and why I think it's an interesting framework, and also mostly talking about the attack framework and also the MITRE ATT&CK for containers, which was released earlier this year. And I'm not sure if you're aware of it. We participated in the work with MITRE to develop that matrix, and I think it's really interesting. And of course, we want to talk about Kubernetes and audit logs. There is a specific set of audit logs on Kubernetes, and we're going to go into the details there. So yeah, my name is Magna Logan. I work for Trend Micro as a security researcher. Okay, good. And information security specialist. I'm part of the cloud and container security research team. I'm also a member of the CNCF security tag team. So CNCF stands for Cloud Native Computing Foundation, which is the foundation that Kubernetes is part of. There are many other cloud native projects that are part of that as well. I helped write and review the cloud native security white paper and the cloud native supply chain attacks as well. And we're also doing some translations of that documentation there. And yeah, pretty much my research so far since last year when I joined Trend Micro has been around Kubernetes security, and lately also around open source security. So there's some stuff coming up on these topics there. And I have a personal blog called K8s.com where I try to post blogs at least once a month or sometime around that. And there is also a link for all my contact information and all the previous presentations that I've given before, either at SANS or other conferences. It's all there, either the slides or videos. So if you want to check that out, it's all that on my blog. Okay, so let's go to the interesting part, right? The agenda for today, it's talking about the MITRE ATT&CK framework, the DeTT&CT as well, mentioned that a little bit, and how it's important to understand your visibility and what can you detect from those logs that you have right now and how to improve that. We're going to talk about Kubernetes audit logs, as I mentioned, and some techniques that are from the MITRE ATT&CK for containers, and some logs like we're going to exploit a real world application, and I'm going to show the logs there and how can you detect those attacks. Before we move on, I just want to say that I've been doing research on Kubernetes for over a year now in Kubernetes security, and I decided to build this kind of GitHub project there as an awesome Kubernetes security list. There is the link on the slides, and I can post there on the Slack later. But yeah, it's a great resource, and a lot of people are participating and helping as well. So there's a lot of links and information on presentations, blogs, books, and etc. on Kubernetes and Kubernetes security, right? It's a very sensitive topic, and a lot of people are trying to understand and learn, and it's also very complex in the beginning to understand all the moving parts. So yeah, there is this project there that might be helpful for anyone trying to understand more about Kubernetes. Okay, so I hope that everyone here has heard or at least played with attack framework, right? The adversarial tactics and techniques and common knowledge from MITRE, right? The globally accessible knowledge base. And we're going to use that for our presentation today, right? It's used as a basis of development for specific threat models and methodologies in many different sectors. And it's very helpful, not just for blue team, but also for red team for attack simulation and all that stuff. But here we're going to focus on the blue team side, on the detection side, and having the proper data sources and alerts to detect any kind of attacks on those environments. And I'm assuming that here you have at least a high level overview of Kubernetes. I won't go into the details of the architecture and everything, but if you have any questions around that, feel free to ask. So this is the MITRE ATT&CK for containers and Kubernetes. I added that myself because there are some techniques here that are specific to orchestrated environments, right? Like Kubernetes and other ones that are still used out there, like Mesos and Nomad and OpenShift and Docker Swarm. So we came up with, together with MITRE and other companies, right? MITRE published this matrix in April this year. And this is the first version of that matrix focused on container and Kubernetes. And so based on our research and data from our honeypots, we were able to provide MITRE with real world scenarios from our attacks that we identified in our honeypots, and we helped them with some of these techniques here. I think we participated in creating like 8 techniques. I think 2 of them were brand new that didn't exist before, and six of them already existed on the MITRE framework, but didn't have the context of containerized environments, right? It's either just focusing on Linux or something like that, right? So yeah, this is the matrix for containers. It's already available, and if you have containerized environments in your organization, I highly recommend that you take a look at that. I just want to note that I'm not talking about the DeTT&CT framework. This is something else, so not to confuse with the DeTT&CT. I know the DeTT&CT framework, I think it came out after I submitted this presentation, and so I didn't have time to really research on it and include in this presentation here. So I just want to highlight that I'm not talking about DeTT&CT, so don't mistake. It might be confusing DeTT&CT and DeTT&CT, right? So I just want to highlight that. So what we're just mentioning here and describing with the DeTT&CT is a framework created by Rabobank, CDC, the Cyber Defense Center. It's not an official MITRE framework, but it's very well known now as assisting blue teams in using the attack framework, understanding how you can score and compare your data log source quality, right? Visibility and detection for coverage and threat actor behaviors, right? So there's the link for the GitHub. It's open source there, and anyone can download and install and start using it, right? Basically, what you can do here, you can use the command line interface for that CLI, or you can use the editor, which is, oops, still loading. Okay, good. So you can use the web editor there for you to add your data sources, your techniques, and your groups, and you have an understanding. Okay, what can I detect with these data sources, right? Can I detect kind of remote command execution or either a container breakout and all that stuff? So I think DeTT&CT is really interesting to know and leverage that. Okay, score your visibility, right? So there's 3 concepts that DeTT&CT uses for that, which are data sources, right? The raw logs of your events generated by your system, security appliance, and network devices and all that stuff. There is the visibility, right? Indicates if you have sufficient data for data sources for with sufficient quality available, and detection, right? Which is really the triggers, the alerts for the attack techniques that you're looking for and that you're monitoring. Okay. But we also need to understand what are Kubernetes audit logs, right? So if you might, Kubernetes is a container orchestration solution, right? To deploy multiple containers and clusters, and you can manage that. And it has a lot of features to maintain what we call the desired state. So if a container goes down, it creates another one and all that stuff. So it's being adopted by many organizations. And I hope that you heard about Kubernetes by now and at least have a little bit of understanding about it. But the problem is that audit logs in Kubernetes are not enabled by default, right? And so they are very relevant for security and for troubleshooting, but they're not enabled by default. And there are some reasons around that, memory consumption and space and all that stuff. But I think it's highly recommended that you enable audit logs on your cluster and you define a proper policy for them. Right? So audit logs here is just a security relevant chronological set of records, right? And answer some following questions, right? What happened? When did it happen? Who initiated, right? And all that stuff. And there are JSON based logs. And yeah, so there's a lot of information there as in Kubernetes, everything goes through the Kube API server. So you have that understanding of what's going on, who did what and why, who started this container, who executed it inside a container or try to escape that container. So you can have that visibility with audit logs. Here's an example of an audit log, right? So you can see that it has a lot of information. There's some interesting fields here. This is not a complete list. There's other interesting fields available as well. There is some blog posts out there that detailed very much which field you want to look for. But here you can see the timestamp. You can see the request URI to the API server, the username and the source IP. So it gives you a little bit of visibility, right, on what's going on and what to look for on those logs. So as I said, audit logs are not enabled by default, and I think that's very concerning. I think that's the second most concern that I have on Kubernetes. The first one being that Kubernetes by default is a flat network, right? Every pod can talk to every other pod on a cluster. So that would be my first one. The second one is that audit logs are not enabled by default. And so it's highly recommended that you enable them for security and troubleshooting as well. And to enable these logs, you need at least two things, right? You need a log path, right? Where you're storing those logs. If it's local, if you send to a remote location, uploading that to a SIEM or to the cloud, whatever, right? And you also need a policy file, right? So what are you going to log, right? What specific information, as previous presentations mentioned here, like don't log everything, right? Because you're probably not going to need it, and it's gonna be a waste of resources. Make sure that you understand what can be provided by those logs so that you log very specific information, because Kubernetes can be very noisy, right? So Kubernetes is an active system. It's always checking if the cluster, what's running is exactly what's specified on the database, the etcd, right? And so to achieve that desired state, to make sure that the configuration of the database is exactly the number of pods and the number of objects running, it's always checking. It's constantly has controllers monitoring that and checking to make sure that those states match, right? And that is the desired state. So it has a lot of noise that you need to be aware of. If you ever deploy a Kubernetes cluster, enable audit logs, you're going to see that it can be very noisy. But yeah, you can set those up on the Kube API server configuration, right? The log path and the policy file. And basically, for the policy file, it has 4 audit policy logging levels, right? you have the none, you have the metadata where you just log metadata from those requests. You have requests, which you can log the whole request of that, that information, and the request and response, which logs everything, right? So you need to be aware of that and choose the level that you want to log to make sure that not just you detect the right attacks, but you also don't overload your system with logging that's not necessary, right? Okay. On EKS, which is the example that I'm going to show here today, I deployed a cluster on EKS for the demo on the slides here. And basically, it's very simple to enable that. EKS is the managed service for Kubernetes on AWS, right? So the elastic Kubernetes service, and that's how you deploy a Kubernetes cluster on AWS. And once you deploy that on your control plane, you can easily enable audit logs on your console, right? You can just go to the logging menu there, the logging tab, and you can see that the audit log first is not, it's disabled by default. All the logs are disabled, and you can enable that. You can enable the audit logs. There is also the API server, the authenticator, controller manager, and scheduler, right? So there's a lot of different components that you can start logging. But for this purpose of this presentation, we're going to focus on the audit logs only. Those logs, once enabled, they go to CloudWatch. So you can see here on the next slide, right? So there's a log group that's created on CloudWatch, and you can see that there is some log streams there as well. So that was for the for this presentation, I created an EKS cluster. And I ship those audit logs to CloudWatch. And you can see here that some samples, right? There's all JSON logs, and this is all the information that's collecting for the Kubernetes cluster. And you can see that it is very noisy, right? So you need to be very careful on what to log and what to look for when you're trying to detect any kind of attack and malicious activities, right? Okay. So the scenario that we're going to analyze today is a threat modeling that I did last year, even before the MITRE container was released. I'm going to drill down in some of the steps here, but basically I did a threat modeling of there is a vulnerable web application running inside the cluster, and that web application is exposed to the internet. And so that application has an RCE vulnerability. So let me move to this next slide. Okay, yeah, that's better to explain here. So the first two steps is the initial access and execution, right? You have a vulnerable CMS, which is Drupal from version 8.5 from 2018. And that has an RCE called the Drupal Gaddon 2, if I'm not wrong, right? And so the attacker finds that web application exposed to the internet, and it gets. There's also the idea here that your cluster is misconfigured, right? You haven't configured your cluster properly, and that's why this whole attack can happen. So you get an RCE, you exploit that RCE, and you get a shell inside that container, right? And the attack goes on doing some reconnaissance on the container that you're in and the cluster as well. So you see that you're in a Kubernetes environment, and then we're gonna see the commands and details and the output of those commands in the next few slides, right? The next step is doing some privilege escalation and credential and access, right? Try to run a privilege container to escape that container that you are and access the Kubernetes worker nodes. You can try to get the cluster admin, which is basically a root on the cluster. You can also access cloud resources. So if you don't know, from the container that I'm inside a Kubernetes cluster on AWS and other cloud providers as well, I can reach the API, the instance metadata API, right? So if I have access to that, then maybe I can get some API keys and credentials there as well. So I don't need to break out of the container to do that request as well. So make sure that you're using the metadata v2 to avoid this kind of attack as well. I can also get access to Kubernetes secrets, and secrets in Kubernetes is a way to store sensitive information, but they're not very secret because in Kubernetes, by default, secrets are only base64 encoded. And as we know, base64, it's easily to decode that. So you can encrypt those, but they're not encrypted by default. So just be aware of that. And secrets has all sorts of tokens and information about service accounts that you can use to access other pods and other objects on the cluster as well. Yeah, and also the service pod account from the secrets as well. And the last two steps here that I did on this threat modeling was the discovery part and the lateral movement, right? You can do some network mapping. We've seen some attackers in the wild, and we're going to see some examples here in a second, that once they compromise a cluster, they start mapping the internal network and understanding what's exposed out there. If the kubelet API, which is an agent that runs on every node, if that is enabled and if they can access that without any sort of authentication, if they can access also the Kubernetes API server, which is similar to the Docker daemon API, you can send commands to that API server to like deploy pods or deploy containers and do all sort of things. And as I said, you can also access the instance metadata API, right? And from those cloud resources, there's all kinds of impacts that can happen. The most common one is the resource hijacking via crypto mining, right? That's the most common one, like 90 to 95% of attacks in Docker and Kubernetes environments, at least according to our data and our honeypots, is to mine cryptocurrencies, usually Monero cryptocurrencies, right? But there's can also be the impact of data dump or denial of service, right? Okay, so let's go into the attack itself, right? I just created this kind of fake website. This is a Drupal website. I just put the information there for this presentation, but this is not an official SANS website, just to be clear here, right? Yeah, so I'm attacking that vulnerable Drupal application, which is running inside a pod that's inside a cluster of Kubernetes and exposed to the internet. There's a URL there to access that application here, right? Okay, so basically, I can exploit the application, the public application, using the CVE. I can also try, there's other options to the exposed dashboard, which was something on Kubernetes that was enabled by default before, luckily not anymore. And there's also the Kube API server that on EKS, for example, it's public by default. So there's a URL, a specific URL for your API server that's public by default. So you need to be aware of that as well once you create clusters on Kubernetes. Okay, okay. So yeah, I can reach the API endpoint externally, and you can see here from the second curl command that easily from the URL I can tell that this is an AKS cluster, right? And I can see that from the URL there, and I know that, okay, this is a Kubernetes cluster, and I can try to obtain other information, the version of the Kubernetes and APIs and all that stuff. Okay, so yeah, moving on to the techniques here. This is a technique for container administration and command. This is from the MITRE ATT&CK matrix, and this is exactly what we found from a command and control server from one of the threat actors known as DeTT&CT. And we published a blog post a few months ago about this attack. And this script here, basically what they're doing, right? If your cluster is protected from the internet is not exposed, the API server is not exposed, then they usually have a hard time targeting your applications. So what happened is, once they are inside your network, that's when they start scanning for all your worker nodes or your EC2 instance or VMs for anything that's running on port 10,000 to 500, 250, sorry, and they're looking for the specific API endpoint of running pods. And like when I was doing analyzing this code and research here and doing the research, like, okay, what are they doing here, right? Okay, 1050 is the kubelet port by default. And if you go to the Kubernetes documentation, the kubelet API is not documented, right? And so I had to look at the code for Kubernetes, the Go code of the kubelet server, to understand, okay, what is this endpoint doing, right? And what they're trying here. But you can see from the other commands below that basically they're looking for any pods running on that node and installing basically the tools that they need to deploy their crypto miners, right? Installing bash and wget and curl and with different commands, yum and apt, and later at the end they're deploying their Monero from the .x2 and x1mr files, right? So basically that's what they're doing here. And this is something that attackers are using in the wild already. So you need to be aware of that. Oops, I think I pressed too much. Okay, going back. Yeah, so once I'm inside your environment, I got a shell in one of the pods of your cluster. There are a few commands that I can run to understand that, okay, am I in a container environment, Kubernetes environment? I can check some credentials. There's a default allocation for service accounts in Kubernetes, so you can check the secrets there as well. And there is a famous tool on GitHub called MI-Contained, which is a container introspection tool that can give you some information about your cluster. If you have the seccomp and AppArmor profiles enabled, which capabilities you have on that container as well. So here you can see that from the compromised container, I trigger a curl request to the API server, and that's logged here as on the audit logs, right? So I can see the user agent, I can see the request URI, and that can give me some information like, usually there shouldn't be a curl user agent triggering requests on your cluster, right? So there's something that you need to be aware. Another example here, same from the same blog post that I mentioned earlier from DeTT&CT. Now they're deploying, they're installing tools to do the scanning on your internal network. They are already inside your network, and they're deploying mass scan and zgrab to map your network quickly, right? And this is from the exact code from the script that we analyze from their command and control servers. And here you can see, okay, now there is a mass scan user agent on my audit logs there that shouldn't be there, right? So what's going on? There's also some Python requests, and you can see the curl user agent here as well. I can share the queries that I did to get those results on the CloudWatch logs as well. I didn't add those here to not get like too much information, but I can share that. Yeah, so basically here is another example, deploying a container now that's specifically through Docker and analyzing that on Wireshark. There's a different abuse that attackers are doing to deliver cryptocurrency mining as well. So like if you see containers being created right through the API server or the Docker daemon API, just be aware of like what's going on here. Should that be happening? And like, is it a legit request, a legit container, right? Another great example is the example here by Duffy Cooley, who works at Isovalent now, and he does a lot of cloud native security work. And basically, he's doing a pod or a containerscape via a privilege pod. I basically broke it down, the tweets that he did on 2019 on the left. For on the right is basically the JSON that he's overriding to deploy his malicious container that's breaking out of that cluster, right? And you can see that here as well on the audit logs. Okay, there's I'm deploying on the namespace web app a pod called root, which with zeros, right? There's also a suspicious there, and there's also, okay, this is happening from a EC2, right? So okay, is that supposed to happen? Is it, what's going on here? So you need to be aware of that and analyze those situations from the escaping to host and exploitation for privilege escalation techniques on the MITRE ATT&CK for containers. I know that I'm almost out of time, so there's another example here as well of a log. Let's see, and this, just the final part here to finalize, is basically, okay, now I have those logs, but it's hard to search that on CloudWatch, the console itself, right? So the idea would be, okay, can I deploy to a SIEM? I can analyze that in a centralized location. I can make some different queries, and the way that I did, and it's just like just for research purposes, but if you have a SIEM already, you can send that to that SIEM. Basically, I deployed Splunk using the Docker image of Splunk, and this is the way and the commands to do that. And after I access Splunk, I can import the logs. So there's options that you can download the logs from AWS and import to Splunk. That's not ideal. It's just for the research analysis. But you can also send the logs from CloudWatch to an S3 and have Splunk collect those logs from an S3 bucket as well. So yeah, just how here, like, I imported the logs from a CSV file that I downloaded from CloudWatch, and I analyzed those on Splunk. So it makes it easier for me to identify any kind of suspicious activities, create the alerts that I want, and also create the dashboards for automated detection and response, and alerting the proper teams on, okay, this is going on. Someone tried to break out of this container, or a container with a suspicious name was created, or something like that, right? So that's easier to flag, and we want to automate that as much as possible. I just added here some, if you haven't played with Splunk before, there's some proper queries and wildcards, and how to make your queries properly. So just to be aware of that. And yeah, some basic search features, and you can also add some things that you find from your logs to your search as well. So just an example there. For the next steps, this is still an ongoing research. I forgot to mention that in the beginning, but I want to automate the log generation and shipping to the SIEM. This is not automated yet. Create some better dashboards and alerts. The alerts that I did was manually, and I haven't been able to create a pretty dashboard that the blue teams can monitor and see, and right away when something going on, something malicious is happening. Link to more real-world TTPs and with audit logs, right? This is just a sample. It's just from one threat actor that we had data from our honeypots and from the command and control server that we were able to analyze. But we want to expand that, especially as probably the matrix attack for containers is growing. There's other tools that you can use to generate more data and help you with those detections. Some tools are also part of the CNCF. One of those is the OPA, the Open Policy Agent, and the other one is Falco, which is basically an IDS for your Kubernetes cluster, and they can help you enrich your detections and help you with your audit logs. I think that's it for my presentation. There are some references there, and I'll share the slides with the SENS team later, and I'm open for questions here or on the Slack. Thank you.
All right. Thank you very much, Magno. So really loved all that stuff there. Obviously, ton of depth. I would highly encourage everyone to download that presentation and review it and really soak in all the stuff he was saying there. There's a lot of actionable things in here, starting from Kubernetes, isn't logged by default, with stuff that you might need and all of that. One question I did see come through that I wanted to ask. Someone said they have trouble simulating some of these attacks. I might have missed it if you had said this, stop me, but is there an easy way that a blue team that, doesn't have, a pen test coming or anything like that can easily do these Kubernetes centric kind of attacks?
Yeah, I don't know if there is a tool that automates that already. There are some solutions, some open source tools like Cube Hunter from Aqua Security that helps you like pen test and exploit those environments. So that might be helpful. But yeah, for those attacks, you need to know the right commands and the right exploitation there. Especially, okay, it's gonna vary, right? In this situation, I exploited a web application that I knew it was vulnerable, but what if the web application doesn't have any vulnerability, right? So how we're going to find that entry point to access the cluster and get a shell into a container. So I don't think there is a framework for that. So that's a good idea to maybe develop that. But yeah, it's right now it's based on our research and the commands that we have. It's either from our threat modeling or from attackers that we analyze on our honeypots.
Awesome. All right. Well, great presentation. Thank you very much.